All right, here we go, section 2. So what are the major pollution problems in streams and lakes? Well, to start out with the streams. Streams can bounce back a lot easier than lakes can. So they can handle a moderate level of water pollution in them. As long as you don't overload them, they're capable of kind of cleansing themselves. So in a flowing stream, the waste can be broken down by bacteria. Now when it happens though, it does deplete the oxygen in that area. So the oxygen level goes down. And this creates an oxygen sag curve, which we talked about earlier this year, but I will reiterate it for you. It's an important thing for you to know. And so this process of breaking down wastes, and so this would be an example of like a sewage or something like that that's running into the water. Bacteria break it down, but it takes some time. It's a process. And so in the meantime, this oxygen sag curve results in certain species, populations in that area that can't handle low oxygen levels. It's going to make them get out of that way. And so here's a stream picture. And so let's say this is your point source right up here. It's pushing out waste into the stream. So a normal, healthy, clean stream might have trout and perch and bass in it. It might have mayflies and stoneflies, which are the small bugs that live in the water, basically. And so there's lots of dissolved oxygen for them to breathe in this particular world. And the demand for oxygen in that area is pretty low. And so when the pollution is introduced, the pollution, there's all the bacteria and stuff are eating up it. And in order to eat it up, they need oxygen to do that. And so the demand for the oxygen in that section grows significantly. And as a result, the oxygen that's present in the water goes down sharply. This is the oxygen sag part of the curve. And so now we have a lot of oxygen demand, far less oxygen present. And so those trout and those perch and those bass can no longer live there because they require more oxygen. And so you have fish that can handle that, like carp and gar that come in, and they're now filling up that stream. As you move down from that, the oxygen demand is falling off, but the sag, the lowest part of the oxygen level, is down here. So we have fish that don't even handle that very well. So the fish leave completely, and you have fungi and sludge and worms and bacteria. That's all that can exist in this area. Some people refer to this as the dead zone. The septic zone is the correct term for it in this particular context. And then as you move downstream, the stream starts to recover and the oxygen levels return and the demand goes back down. Carp and gar can live on this end as well, and then the trout and perch and bass and stuff can come back here. So there's a section in here while the water's flowing this way that results in this oxygen sag curve component. Okay, very similar results happen when we add thermal pollution in. So if you're down from, say, a power plant and it's using water to cool the reacting space down, they're going to push out hot water in the system. You're going to see a similar reaction here as you would with a waste pump being pumped out. And so when it comes to developed countries, most developed countries have very few point source pollution problems. Water contamination is still a problem, but there's not as much point source pollution problems in there. There are lots of accidental and deliberate release of toxic chemicals by industry and mines and sewage power plants. And there's a lot of non-point runoff from agriculture, pesticides, nutrients, croplands, all that kind of stuff. So we're still getting it, but we don't have a lot of point source stuff anymore. And if it happens, it's usually an accident. We have more non-point problems here. By contrast, developing countries have a lot of problems in both contexts. It is a major problem across the board. If you look at the streams down here at the bottom, they're just, ugh. There's a lot of untreated sewage. There's a lot of bacterial agents present, and there's all kinds of industrial waste present in these streams. And the reason why is most of these countries can't afford any kind of water treatment plants whatsoever. So there's no way to cleanse the water. Many don't have even water quality laws that say it has to be a certain way. And if they do, they don't have the money to enforce those laws. And then, of course, the problems are made worse by the people in those countries using that as multiple sources of things for themselves. It's their drinking water. They bathe in it. They wash their clothes in it. And there's this combination that it just creates this perpetual waste stream. And then the case studies. I talked about India, Ganges River a while back when I talked about the turtles being released, but it's a good example. There's lots of things that are affecting the Ganges. Religious beliefs, cultural traditions, poverty, and a large population are all causing really bad pollution in the Ganges River. And so, first of all, there's millions of people that live along the banks, and they're considered holy waters. They do religious ceremonies and stuff in them, and so they're bathing and drinking from them, carrying out their religious stuff on a regular basis. Most of the sewage that gets put into the Ganges is untreated. You'll see animal carcasses in it. Hindu believes that cremation and putting the ashes into the Ganges is a very sacred thing, but a lot of people can't afford the cremations, and so you have bodies that are decomposing and messing with the dissolved oxygen levels, and we're seeing oxygen sag curves. So real problems around the world. The Ganges is one example. Now we can talk about lakes. Now lakes have real issues with pollution because they don't have water that's moving. Lack of water moving makes it becomes prone to stagnation quite easily, and so that's a real problem. So dilution of pollutants in lakes is not very effective then, and so they can build up. There's not any real mixing that's happening, and there's very little flow in those lakes, and so as a result, we have some real problems with them. They're usually layered by temperature, and they don't do much mixing, as I talked about earlier. And so if a pollutant gets in there, it kind of stays in one portion and doesn't flow around very much. And so as a result, if you put pollution into a lake, it kind of gets stuck in there. And so they're very susceptible, especially to runoff. If there's a lot of runoff into them, usually you can create some really poor lake conditions. And then, of course, human activities at lakes promote some of those behaviors, whether it be boating and fishing and all that kind of stuff, but a lot of times it's agriculture. Ag is putting in fertilizers and stuff into these things. It's getting a reaction to occur, which results in eutrophication, which is on the next page here. Eutrophication is where there's too much nutrients in a lake. And so there's too much nutrients present, which makes the bacteria and stuff in the lake shoot up like crazy. And you have excess bacteria and stuff present, algae present, which then absorbs all of the oxygen in that area, and then you get what we call dead zone kind of stuff. So overabundance of nutrients leading to really murky, cloudy water, and then a lack of oxygen in that water. Allotrophic lakes, remember, those are the opposite. They're usually very low in nutrient levels, and they don't have a lot of life and vibrance to them either. Eutrophication usually comes as a result of cultural eutrophication in the United States, where human activities are accelerating the input of those nutrients, mainly phosphates and nitrates from fertilizer into the lake. And if you read down here, this is an interesting statistic. 85% of the large lakes near population areas, large populations, big cities in the United States, all have levels of cultural eutrophication where we have altered the balance and created problems within the dynamics of those lakes. Now, eutrophication, the biggest problem eutrophication can cause is it can cause what we call fish kill events. And so if you have a case where you have too much nutrients in the soil or in the water, excess nutrients, you get big algae growth, algae blooms. As these algae die off and eat stuff, they decompose, which sucks all the oxygen out of that area, getting low oxygen. Get that oxygen sag curve we just talked about. With an oxygen sag curve, the fish can't live there, so it can result in thousands to tens of thousands of fish die at a time. There's pictures of them down here. These are both in the United States. And you can see the fish just piling up because there's not enough oxygen for them to breathe.